Hi, as you may already know, the very fascinating creature known as the sea cow, or the dugong, has been in a steady state of decline over the last several decades, largely throughout the regions of the northern Great Barrier Reef and the Torres Strait. Aerial surveying methods used since the 1940s have been the main method of population estimates for these regions. Unfortunately, this method continues to provide inaccurate population measures, largely due to its outdated protocols. Kenneth and his team of scientists have some suggested recommendations which they will believe will improve the accuracy of aerial surveys. These can be found in the following journal article published in 2006. The standard method of aerial surveying consists of flying at a height of 137 metres over randomly chosen transects, in which observers in the plane count the relative number of dugongs in their respective line quadrants, from which population estimates are directly extrapolated. It is, however, believed that by mathematically accounting for environmental variability that decreases observer viewing capacity, the accuracy of aerial surveys can be improved. This led to the first exercise, whereby the depth of visibility of differing water bodies was determined. A helicopter was kept at the normal height of 137 metres, from which an artificially produced dugong was raised from an unrecognisable depth, with the depth of first sighting being recorded. The team of scientists also realised that the average time which the dugong spent at these differing depths needed to be determined. To determine this value, 15 wild dugongs were captured and depth trackers was attached to each. From this data, specific ratios were determined which can be used in the following formula. These ratios describe the probability of a portion of water being sampled, the probability that a dugong was at a visible depth, and the probability that a dugong was spotted provided it was at a visible depth. The variance for these ratios was also calculated to allow us to understand the potential variability of the final value. As expected, turbidity directly influenced the maximum depth of detection, as represented by the differing depth values. Optimal sea state and marginal sea state also had a direct influence on the depth values. By factoring into account the ratios described earlier with their corresponding variances, the new methodology displayed markedly different population estimates than the old method, up to 12% variation from the northern Great Barrier Reef. Unfortunately, the actual population number for the northern Great Barrier Reef is not known, which makes comparing the new and old methodologies extremely difficult. Kenneth and his team of scientists do, however, believe that by mathematically accounting for a greater range of environmentally heterogeneous variabilities, that a greater degree of control can be implicated on surveying techniques, which should improve the accuracy of aerial survey techniques for a wide range of animals.